Well, welcome to Mod 5, Lesson 19. And our lesson objective today is going to create a Venn diagram based on the attributes of quadrilaterals. Now, you're really going to be doing a lot of this tomorrow in class, but I'm just going to kind of wrap up our flowchart and give you a little bit of a Venn diagram that you should be able to use to help you tomorrow. Now, essential question is, how can I categorize quadrilaterals based on their attributes? And it's been really based on how many parallel sides they are and angles. So if we keep that in mind as long as we're doing it, we'll be great. All right. So we're still working on MAFS 5 G23, which understand the attributes belonging to a category of two-dimensional figures also belong to all subcategories of that category. All right, so here's our flow chart. And we stopped at trapezoids. And last night, we actually put parallelograms in there. And the biggest thing we knew that a trapezoid is one set of parallel sides. In order for a parallelogram, we had to have two pairs of parallel sides. Okay, and opposite angles and opposite sides were equal. And in order for our trapezoid to be a parallelogram, it had to have two sets of parallel sides. Now we're adding in a rectangle like we looked at today. A rectangle has four right angles, but it also has two sets of parallel sides, so it's also a parallelogram. Now, not all parallelograms can be rectangles because they don't all have right angles. Now, underneath rectangles we learned today were squares, and squares were all sides were equal. And that was kind of unique because a rectangle also had opposite sides that were equal. Well, a square opposite sides are equal. So that means and it also has four right angles. So a square is also a rectangle. Now, not all rectangles can be squares because not all sides are equal. Okay. Now, with that, then we put in a rhombus. Now, rhombus was kind of unique because all sides were equal like a rectangle and opposite angles were equal. And when we looked at a square, we found that all sides were equal and opposite angles were equal also. So a square could be a rhombus, but not all rhombuses are squares because the angles aren't always 90 degrees. Okay. Now, if you look at the rhombus, it has two sets of parallel sides. So that means it is a parallelogram. Okay. So it's not a rectangle because it doesn't fit the category of rectangle, but it does fit a parallelogram. Now, one of the things, let me see if I can get my pen here. One of the things I want to bring up at this point, and we haven't, my pen's not working, so I'm going to try to do it with a keyboard. There's a unique thing about squares and kites, and also rhombuses and kites. Okay? Now, kites, not all kites are squares, not all kites are rhombuses, but rhombus could be classified as a kite. Okay? And a square could be classified as a kite. And I'll show you why here. Okay, so let's take a look at a couple things with them. Here, and I'm going to try my best to draw it by hand, is a square. Okay? Here is a rhombus. Now, a kite looks something like that. Now, the unique thing about a kite is that adjacent sides are equal, not opposite. Okay? So that's what makes it unique. But if I come over here to the square, I can see that adjacent sides are also equal. Okay? Now my rhombus, I can do the same thing. Adjacent sides are equal. So that's what puts them in the classification of a kite. Now there's one other very unique thing about them, is that if I took, let's say if I take and I do a dotted line from vertex to vertex, and I'm just going to draw a straight line, make it easier. If you notice in the center, it made an X, and there's actually four right angles in there. Okay. Now, if I come to my rhombus and do the same thing, it also, in the very center, I got that X again, and I got 4 right angles. And my kite, if I do the same thing, won't draw that far. I'm sorry, I don't know why I won't draw in the center. Okay, but I end up with that X and 4 right angles. So that's something that's very unique to a kite, a square, and a rhombus. Now that means that a square could be classified as a kite, but a kite, not all kites are squares. And also a rhombus can be classified as a kite, but not all kites are rhombuses. Okay? All right, so let's take a look at this now. And we're going to put a little bit of a chart together. And we're starting here. Okay? Notice I have a quadrilateral, and this is a 4-sided quadrilateral. Okay? Now, inside that quadrilateral, I have trapezoids. And a trapezoid has to have at least one set of parallel sides. Okay? And you can see here, I have one set of parallel sides right there. Now, inside the trapezoid, I have parallelograms. Now, a parallelogram has to have 2 sets of parallel sides. Okay? Now, inside the parallelogram, I have rectangles. Okay? Because rectangles can be parallelograms, but not all parallelograms are rectangles. Okay? Now, inside the rectangles, I have squares. Okay? But if you notice, rhombi fits inside the rectangles. Excuse me, the rhombi is actually outside, but a square can be a rhombi, or we call a rhombus. Okay? And this last thing you're going to see is a kite. Now, a kite is in there with dashed lines because a kite is including squares and rhombuses, but it's not including anything else. Okay? All right. Now, when we come to class tomorrow, you're actually going to be creating Venn diagrams. And Venn diagram is where you're going to have a couple circles, okay, and a mat, and you're going to have to glue the shapes in there and label them, okay, as far as their categories, okay? So I'll see you tomorrow. Have a good evening.